them to use their brains and not ours, to address the notions of motivation, the lack of wish to think, and all of those things that you've talked about today. And we're going to consider some of the approaches that come from coaching to that. And the first one, you can summarise as ask rather than tell. Okay, somebody asks you a question in class, you can do one of two things. You can, yeah, exactly. You can either answer the question, or you can ask them another question which makes them think. So it's about, instead of solving their problems for them, it's about getting them to solve their own problems. I had an extreme example of this when I did a lesson observation as a PGCE tutor. Went into a local secondary school, small boy at the back of the room doing everything he shouldn't be doing. I'm supposed to be the observer, couldn't sit there any longer, went up. What's the problem? Can't do it. What can't you do? All of it. Heard this before somewhere? Mm-hmm. Okay. So I go laboriously through the first sentence. Do you understand that? Yes. Go through the second sentence. Do you understand that? Yes. Third sentence, small boy's getting a bit bored. He says, it's that I don't understand. So we get to the nub of the problem. And all I did was to ask him questions about the things he was throwing at me. And eventually he said, I can do that now. But the bit that brought tears to my eyes was he said, you've made me feel really clever. Now, isn't it sad that a visitor had to go into an educational establishment to make that small boy feel clever? Then he knew what he was doing, and he refused to stop when the teacher told him to stop, because he was experiencing success. So I think we need much more of that attitude in our classrooms. Don't give them the quick answer. The answer is 10. Divide A by C. Make them work out the answer for themselves so that they're engaged and so that they experience success, because we all know there is no motivator like success. Why do teachers ask questions?
Check understanding.
Check understanding, yeah. Next.
So people are listening.
To see that listening. That's a very good one, and that's an underestimated one, yeah. To check people are listening. Anything else?
To challenge them.
Challenge. Brilliant. To make them think. There's 4. One more?
To see if they're understanding the subject you're trying to
To see if they're understanding. Right. So it's not just about the right answer. It's much deeper than that. Can you find a mini whiteboard on your desks and a pen? And we'll do a very little bit of this. Because a lot of you said you hadn't used mini whiteboards before, and they actually contribute to the motivation thing.
Thank you.
Okay, I hope the pens work. Apologies if they don't, because people borrow them and then put them back even when they don't work. So I want you to do something really, really simple now. I would like you to write down the area of a rectangle 4 by 6. Units unimportant. Area of a rectangle 4 by 6. Okay? And what number do you get? Put your number, big writing, on the board. And as Philip was saying, if I count down 3, 2, 1, I'm going to hold it up and show. And if we're lucky, we'll all have the same number on it. Okay? Notice we've also got calculations on there. We've got people writing down formulae. We've got people writing things down which help them to work. Thank you. You can put them down now. Right, turn your board over, and I'd like you to draw an area of 24 on the back of the board. On the squared side, that is, if you haven't used the squared side to start with. So we've swapped from a closed question to an open question. Right, okay? Hands up as far as you've got. Boards up as far as you've got, sorry. Right. Okay, so notice what's happened. An awful lot of you have had 4 by 6 on the other side. So you've done a 4 by 6 rectangle. Some more creative people have got shapes with bumps on it. And we've got an advanced learner here who's had a go at a triangle.
Well, I've doubled up my rectangle and then halved it to make the triangle.
Okay. If you've got somebody who's a really fast learner, you can challenge them to draw a circle with that sort of an area, which is a bit more challenging. So you can open questions up. You can ask questions. People can respond in the way that they want. So I'd like to think you might go back to your colleges and think about using these mini whiteboards. They cost £1 each. The pen situation can be managed as you manage the rest of your classroom. If the boards are too expensive to buy, get a sheet of paper and laminate it. If you've got a dyslexic learner with a preferred colour style, get a coloured piece of card and laminate it and just give it to them and let them carry it around with them. It's going to cost about 10p or something. Okay? Learners can scribble on them, yes, in the doodle sense, but often they do a lot of thinking on them as well. We've had a lot of talk about transformations, and how to do it, but one of the things that learners actually find difficult is the notion of algebra per se. This one, there's a nod. Okay.
Me too.
You too, right, okay, well we'll do what we can. Now, transforming equations means you have to understand what the equation means, yes? It's not the formula, it's not some figures, it actually has got meaning, and you have to understand where it's come from. And in that box there is a resource about creating and solving equations, and the techniques in that are applicable to transforming equations too. So let's assume we're going to make an equation. Would you like to give me a letter, preferably one that wouldn't be confused with a number? Any letter of the alphabet you choose?
Z.
Z, right. There are no pens in this room for work.
With an arbitrary place, so it doesn't look like
Okay.
with a Z.
Okay, that is now a Z, still not great. Okay. Choose a number between 1 and 10 that Z might be equivalent to.
9.
Okay. So we've written down our first expression stroke equation. I may or may not be able to do this. Okay. Now what we're going to do is to make that more complicated. Okay? And we're going to make it more complicated by either adding, subtracting, multiplying or dividing and doing the same thing to both sides. And various bits of BODMAS structure will appear as we do that. So what would you like to do first to both sides of that?
Times it by 3.
Multiply it by 3, okay. So we're going to multiply both sides by 3. So what will we get on that side?
3 Z.
Right, okay. And what will we get on that side? Oh, that's a very smelly pen. Right, okay. So let's have either addition or subtraction next. Any offers from this side? What would you like to add or subtract?
Minus 5.
So far so good. 27 minus 5 is 22.
No,
Oops.
yeah.
Right. Sorry. Okay, so that's what we're doing, that's the result. Okay? Okay, let's have division next. And I'm going to cheat and divide by 2. Because it's late in the afternoon and I'm getting tired. Okay, so we've built up a fairly complicated sort of equation there. We might then decide that we're going to add something on. Now I am skipping blithely through the fact that that is 3 times z, that means it's the whole thing divided, that I need to put the 6 separately because I've done that last, because you all understand that. But at various stages you will find your learners may not. Now, if you wanted to solve that equation, you could all probably tell me, without looking at all this stuff up here, where this has come from. The last thing that happened was addition by 6, then divide by 2, then subtraction by 5, and then multiplied by 3. And if you take the learners through the undoing stages, by doing the opposite in every stage, so here you take away 6 to take you back to that stage, and so on, you get the learners developing a sense of what an equation means, because they've seen it develop. Now, I'm not saying that everybody's going to want to use that method to solve equations every time, but it gives them an understanding of that this is not some mysterious thing that's come out of the air. It's got a structure, and it's got a structure for a reason. And we cannot teach them all in the same way, because they're all building on different knowledge, and unfortunately you've got to be master of all the maths that they bring in with them, all the different ways of multiplying, dividing and subtracting. And Ian whispered in my ear, he said, nobody's mentioned place value yet. That is the one thing they really need to understand inside out. 1 or 2 very, very small final points. Choice of language, we've touched on that today. How you say things and your assumptions make a huge difference to the learners. If they come in feeling failures because they failed their GCSE, because the teacher at school has told them they're thick, you have got, by your questioning, to ensure that they get right answers, you've got to praise effort as well as or instead of attainment. Because if you just praise the answer, the process of getting the answer and the effort that's been made to get the answer go unvalued. So remember to praise, gosh, it's taken you a long time to do that, well done, rather than, oh, you got the right answer in 30 seconds, that's fantastic. Be relentlessly positive. That will be a challenge. Some of the learners you meet, it's very hard to find the positive, but it's there. And this is, I haven't really got time for that, but there's useful linguistic tips, like when you ask them to do something, give them alternatives, both of which you want them to do, or phrase your questions in positive ways, assuming that you can do that. Right, we're going to do transforming equations. You'll be able to do that, won't you? The assumption is that they can, not the assumption is that they can't.